There are a couple of ways we could go about solving these equations. But if we look at the original equation, original set 38 equals t d0b to the 7th, 8 equals t0b to the 40th, we could, for example, solve the first equation for t sub d0 and substitute that result into the second. That would eliminate t to the t d0 and allow us to solve for b. Alternatively, we could solve for b and plug that in here and allow us to solve for t d0, because that would eliminate b. But what we're going to do here is we're going to do something a little different. This is pretty slick. We just divide the top equation by the bottom, because then our t d0s will divide out. That's going to eliminate t d0 all in one step, and we're going to have 38 over 8, which is here, equals b to the 7th over b to the 40th here. And of course b to the 7th over b to the 40th is b to the negative 33. 38 divided by 8 is 4.75. We end up with b to the negative 33 equals 4.75. Now how are we going to solve this? Well, perhaps the most direct way to do it is to take the negative 1/33rd root of both sides, or the negative 1/33rd power, the negative 33rd root. Take each side to the negative 1/33rd power, and we're going to very quickly get a solution. So let's look over here at how we do that. If we take the negative 1/33rd power of both sides, then we're just going to get b to the negative 33 to the negative 1/33rd. We multiply exponents and get b. On the right side, we get 4.75 to the negative 1/33rd. And calculating that in a calculator, we get 0.954. At this point, we can plug in then 0.954 for b, and we plug that into the first equation, which was 38 equals t d0 times b to the 7th. We plug the 0.954 in for b into this equation, and we obtain this equation, and or this solution for t d0. We easily plug that into our calculator and get t d0 equals 52.8. So our modulus td equals 52.8 times 0.954 to the t. Now, as you know, the next step is to compare our model with data. But before we do that, we're going to digress just a little bit. There's another way we could have gone about solving for b if we don't understand, or it doesn't occur to us, or whatever, to take the negative 1/33rd power of both sides. We could use logs, because we notice that we have something in the exponent here. It's not the variable, but we know we can flatten this out if we take the log of both sides. So if we take the log of both sides of the equation here, we're going to get, by the laws of exponents, log of b to the negative 33rd is going to be negative 33 log b. And over here we just have the log of 4.75, which tells us that the log of b is negative log of 4.75 over 33. And then we use the inverse function property. If the log of b equals something, then b equals 10 raised to that thing, so that this becomes the power. And 10 to the negative log 4.75 over 33. This is just a number that we can calculate, and we do, and we get 0.954. In agreement with what we got over here, and that's certainly not going to affect anything from this stage on. So there are two ways to get to 0.954. Neither one of them particularly difficult. And now we have this model TD equals 54.8 times 0.954 to the t. We can compare this with the actual data. The data that we obtain, for example, well, let's back up a second. This is our TD. Our temperature function, we're going to have to add the asymptote back into this to get the actual temperature. Remember, TD was the difference between actual temperature and room temperature. So since the temperature is 27 more than TD, we're going to add 27 to this expression and get this model for the temperature. Now, looking at the graph, we estimate that the temperature at t equals 25 minutes was 41. Now, actually, somebody estimated 41. I thought it was closer to 42. And so did some other people, but we accept the estimate. and we just go with that estimate and see what the result is. Okay, well, we evaluate t at 25 by plugging 25 in for t. Now evaluate big T at 25 by plugging 25 in for little t. And we obtain what you see here, which you can easily calculate, gives you 43.3, which is not a bad comparison with 41, even better with the 42, which is what a lot of people thought it should have been.